First of all, let me start the talk. And it's very happy to have all of you here. And the presentation I'm going to deliver today is about the blockchain for full lifecycle management from design, construction to FM. So in the following, I would like to talk about different applications on blockchain for the different stages of the full life cycle. And I'm from Hong Kong University, as I mentioned, and then same city as Professor Wilson Liu here, who will give another keynote soon. So this is actually my brief introduction, but I'll try to cut short. Basically, just for the information is that we also work on only BIM, and we also work on dual twin. Today, I will not share too much about the dual twin, mainly focus on the blockchain application, but we but later I will mention about we try to use dual twin and link with different technologies, including robotics, etc. And we also work on smart city. And that is why I think when we talk about the blockchain application, it's not only about the project-based or building-based, but we also consider the security in a bigger scale. And in the industry, I'm happy to get involved in the Hong Kong Construction Industry Council, particularly the development of BIM, promotion of BIM, etc. And then we also work on green building. We have a BIM lab since 2010, and basically when we talk about BIM, we are talking about building information management. So I think I agree with many of us, and we actually target about the construction digitization. And before I start, I would like to thank my whole team. And I actually know that a couple of my students will also present in this workshop. I actually borrow some of the slides or steal some of their slides. And then basically what I do is I just try to gather the work of different group members and then have a holistic view in what is happening in our group. So, so why we work on cyber security? That's why I would like to remove this bar. Anyway, okay. So anyway, that we can remove this bar. And okay. Anyway, so so why do we focus on the cyber security? In Hong Kong, for the information, we actually focus on the construction digitization, and in particular, we not only focus on BIM. BIM is compulsory since 2018 for all the public projects in Hong Kong. But actually in 2021, we tried to do one step forward is that we want to digitalize the whole construction. And particularly, we developed a roadmap called the Construction Digitalization Roadmap, and we have some commitment by 2026. For example, the full adoption of BIM, full adoption of the CDD, etc. And because of that, then we can foresee that when we try to integrate the whole industry, it becomes digitalized, then security is very important. And particularly, if we also look at the ISO standard, okay, and then maybe I move this one. The ISO 19650 already talk about the security minded. And when we talk about security mind, it's not only about hacking. It's actually about the availability, the authenticity and integrity, etc. So you can see that actually, even though we maybe now have a small group, but I do feel that actually security or particularly blockchain will be the future, because as we try to make our information, our project, or even our building become more digital. So it's actually very important, and I will expect that it's more and more important. And particularly, we talk about data is the new oil. Okay, so we should protect our data. Imagine that if we have the government building, okay, we talk about having BIM for all building, and then including prison, including maybe the president house, etc. Then if those information leak out, it could be very big problem. So I think you probably watch the Hollywood movie, and then if the floor plan of those security, those very sensitive government building leak out, actually is very dangerous. So that's why I think there's a need for us to use the blockchain or other technologies to enhance the security of our building. So that's why, actually a few years ago, we started to consider the security of BIM or the digital construction. And we have a review paper. I suggest you to take a look and then give us some comments. Particularly, we consider there are several aspects of the security we need to consider. For example, how can we consider the security in terms of the data ownership, the data sharing, when we federate the model, and also how to make sure the information actually will be have a smooth workflow. And then we also identify some security holes or security needs in terms of the data level, network level, and also system level. And in particular, we found that encryption is very important. So when we talk about security, encryption, particularly there are different kinds of encryption. For example, it's symmetric or asymmetric. So both actually are important. And then we also are studying how we can encrypt the data. At the same time, we still can search the data. Okay, so search the encrypted data. So you can imagine that, for example, if we have a PDF password protect, you basically cannot get access. Okay, but is it a way that, for example, the concept is we can password protect or maybe encrypt the document, but still there's some keywords I can still search. So this is actually some kind of interesting topic that we are studying. And then at the same time, if we share data, can we share in the way that we also keep track of all this data using blockchain concept? So that's why we started to look at the use of the blockchain with the BIM and also CTE. And then with this, then we can achieve different techniques, for example, irreversible, the traceability, etc. So with that, then basically the whole concept of the blockchain, I think of you probably know, is that based on that, then we can use the digital signature, then we can have the asymmetric encryption. At the same time, we also have the key management so that we can also enhance the symmetric encryption. And then we may also have one-way encryption. Okay, for example, hash it. We hash it, then we have one-way encryption. And also we can do the re-encrypt. So later I will share the scenario that, for example, in a project, then we have a new member joining. Okay, then we need to re-encrypt the data. Okay, so this is something that we may also consider. So this can enhance and make sure that we can really achieve what have been mentioned in the ISO 19650. And finally, we can also talk about the decentralized the data. So that's why we try to consider this kind of framework. Okay, we just talked about earlier. Professor Connick have mentioned about the dual twin and then how we can make sure that the data can be kept updated. So our idea is that whoever contribute the data should be responsible for the data. Okay, and even when we try to push BIM technology, we also have this kind of concept. So for example, I don't care whether it's architectural BIM model or structural BIM model, etc. Whoever contribute that model, you need to make sure that it's updated. Okay, and then we also have the concept about not only BIM manager, we also have the concept of BIM auditor. Okay, so we need to audit that. If we apply this one to data management, okay, then probably it's also the same. You can see that the concept is, for example, the architect need to make sure that the architectural model will be updated. And then, but we cannot share all this data, okay, in the blockchain because the file will be too big. Okay, for example, we are talking about the BIM model. We work in a real project. The BIM model is 1 GB. Okay, so we cannot really put the whole thing in the BIM in a blockchain. But the concept is we hash this one, okay, and then we just store the hash code. At least if someone try to cheat, then we can find out that, oh, the model has been changed, okay? And then this can make sure the traceability of all this data. So in this way, we can still make sure it's a decentralized management, and then the big file will be stored in the IPFS, but at the same time, they share the same link, okay, the same chain. And then we have this concept and apply to many applications for the whole life cycle. For example, the design, e-tendering, carbon auditing, document versioning, issue management, cost management, and facility management. And in the following, then I will touch on each of them, and they actually have been touched on by different group members. So first one is about design. Okay, design actually is important. I think most important is traceability, because sometimes when there's any issue or any change of the design, then people want to point fingers and see how comes someone have changed the design without notice. Okay, and then so that's why we try to see whoever make the decision is not only verbal, we put it as a record and then put it in the blockchain so that no one can change. And then this is actually one example that we put design change and put it in blockchain, and then we actually put this one, and then we have the blockchain data structure, and then we also put this one in the smart contract so that it's automated. We also have the signage and the e-sign as the signature actually will also be part of the blockchain, something like that. And then with that one, then we have the whole workflow. For example, we have the transaction, and then we have the upload. When people try to upload the updated model of the design model, then we need to go through the endorsement, and then we need to go through the validation, etc. by all the people, all the relevant people. People need to sign. Okay, so but instead of paper, then we try to do a paperless signage, and then whoever have signed, then we actually have a record who have signed, and then make sure that they are liable of all these design changes. And then we also apply this one to this kind of platform about multiple to one mapping. And then we actually try to test the performance of this kind of the blockchain application to the design. And then we found that actually, we got the feedback that in design, actually they go through many iterations usually, okay? So if we try to add this one, then will it slow down the system or slow down this design process? So that's why we try to measure the performance of the blockchain platform, and it seems that actually it will not. Okay, so basically, just one iteration, then it takes only like a few several minutes. Okay, so and it actually can be in parallel. And then so with this one, then we try the existing platform. For example, we solve the issue, and then we have the model revision, etc. But with the distributed blockchain platform, then because it's distributed, things can be in parallel. Then we found out that actually the time actually can be saved. So this is actually the design. And then we actually borrow the same concept about the decentralized database concept to the e-tendering, because we also, when we talk about the design, and then when we talk about the talk to contractor will say that, how about the e-submission system? And then, for example, e-submission system, particularly about the tendering. And then what we consider is that for tendering, usually it will have a lot of, for example, it's the same as maybe for example, we submit the proposal, it's the same. So people are worried that when we submit something, then someone will still change after the deadline. So that's why, for example, the public sector would like to have some kind of the timestamp or the secure, irreversible time, the tracking of all those tender documents that has been submitted. So first of all, we try to study the whole tendering submission system, and then no matter it's by contractor or government, and then we try to put this one and automate this one using smart contract. And in particular, we have talked to those contractor and then try to identify what are the key information that will be stored. Okay, and then this one is only one general or a generic data model. But of course, for different projects or for different clients, then probably we can add on some other terms or some other attributes that will be important. But what's important is the workflow and also the concept. And then you can see that actually they have different interactions. And then at the end, then we implement this one so that we can put this one as data segregation. That means the data actually will be uploaded, but at the same time it will have two copies: the centralized copy and also their own copy. And then we can make sure that all this data will be synchronized, and then also have the traceability. And then with this concept, after the submission, then it's about the construction. And then during construction, one project that we are collaborating is actually a big construction project involving like 100 contractors, subcontractors, etc., and material vendors, etc. So then what I was told is that even for example, for they have the facade system, they have the mechanical system, and then different zone may have different suppliers, different engineers, etc. And then you can imagine that each week they update the model. Okay, and then so how many models they need to keep track, and particularly they have dependency of the model. They need to make sure that the architectural model update will be reflected when the structural engineer design. Okay, and then the MVP will try to modify based on the latest version of the structural model. So we have the architectural, structural, and the MVP. Okay, and then so you can imagine that, for example, if the MVP refer to the old version of the architectural model, then all the changes actually is useless, because basically the architectural model has been updated. You still use the old version to do your design, then basically it's no use. So that's why what we try to do first of all about the version management is that we want to identify the dependency. Okay, and then what model depends on what zone depends on what, and then what trade depends on what. And then if you try to upload some model, then you need to make sure the system or we try to make sure that if you upload the model, we need to make sure that you actually have referred to the latest version of the upstream model. Okay, otherwise then whatever you do actually is useless. Okay, so yeah, so that's why we have identified the logic, and then we try to use smart contract to make sure this kind of dependency is enhanced and guaranteed, and then we also consider the blockchain model. So this is actually the first part. Second part, in the construction, we always face is the issue. Okay, for example, we talk about the design change, but let's say if there's any comments. For example, I don't know about Germany, but in Hong Kong, there still will be design change during construction. Okay, and then many contractors complain. Okay, and it's very messy actually. So that's why what they are facing is that if they have any changes even in the construction phase, then they want to see who actually have made the order to change. Okay, and then they want to put a record of that. So at the same time, let's say if someone decide to change, then we compare what is the updated design and then the old design, and then we have diff logic. So we have two IFC model. How can we efficiently compare the two IFC models, something like that? So first of all, as I've mentioned, we first of all need to identify what's the dependency logic. And in this case, we just consider the architectural, structural, and MVP. And then we try to, of course, we also have the facade model. We also have other zones, etc. And then we, in the blockchain data model, you can see that we also mention about the depends on. Okay, so the model hash. Okay, each model have a hash. And then we also discuss many practical issues. For example, how can we make sure the model really depends on the updated model of the early trade. So, for example, the architectural model have a model hash, and then we actually ask the B modeler of the, let's say the structural model should have this model hash in the B model. Okay, so that when we really trace the B model, we will not have some cases that people will cheat. Because I was told by my friend in the industry that people in the industry like to cheat. For example, they may just change the file name and then think that this is actually a new model and just upload. Okay, so without a change of the content. So we actually require them to have the model hash of the updated model of the upper tray and then put it in the model. And then another thing is we also have the smart contract to automate the process. I think you probably can expect this one. And also we have the blockchain model for example, for upload, we have our data model, and then the end I mentioned about it depends on. And then for example, the issue and the resolutions, we also have the corresponding date, and then who actually made the order, something like that. And then you can also see that the diff hash. The diff hash basically means that when someone try to issue the change and then have and then upload a new model, then they will also the system will also compare with the old model and then put a diff. And then this diff will generate a hash and then make sure that, oh, this is actually the relevant model. So you can see that basically it's like the check and balance, okay? So it's not only that someone upload the model and get the job done. If there's any problem, then we can still chase back, and then you can see that there are different mechanisms or different ways to make sure that the file is really the correct one. And then so that's why we have this kind of concept and apply in the actual platform. And in the front end, you don't see any change. You just can see that, for example, for every model, when people upload, then they need to have the e-signature, they need to go through the accountable, the inform, etc., all this. But at the back end, actually is linked to the blockchain platform. Okay, so for example, for the issue, it's also the same. When we link a particular command, etc., then all these issues actually is also blockchain. So we also measure performance, and similar to what I've demonstrated, adding the blockchain, the blockchain part actually will not add burden or computationally on the system. But in terms of the Beam versioning, then we can not only do the version change and also the version dependency, but something that we identify is that we cannot automatically really do the version change or automatically make sure the version dependency, because what we have done is only hard code. Okay, hard code all these things. But is it possible that we can group them? Okay, for example, we can group all the design and then group all the maybe the construction or something like that, and then make it as different branches. Okay, so the concept is like this. We try to use this dependency and then have the dependency tree and then group them and then become different, we call the swarm. Okay, and then for this different swarm, and then we still mix up this one, but on top we have some kind of the logic and ontology to make sure that this can be automated. And then in terms of the dependency, we also have this kind of branching tree. So for example, you can see according to this code, we have the left one is the architectural model. What's that? Oh, okay. Yeah. So this one is the architectural model, structural model, and MDP model. You can see that the structural model depends on the architectural model. And then we also have different versions. Okay. So we have the PO2, PO3, etc. So we want to make sure that this one actually will, the MDP actually refer to the newest version of the architectural model and structural model if they have been uploaded. So all this actually becomes the branch, okay? And then we consider this branch in the smart contract, okay? So that when people upload and then in the smart contract is not only I send and then get it back, okay? It also considers the dependency in the smart contract. So that's the concept, and then we implement this one, and then we also measure the performance. And the performance, we can see that with this one, then we also can save some time, like 20% time. And then besides the construction, during construction, then we identify another application, which is about carbon footprint. Because one project that we work on, they try to make it as a zero carbon construction. And then they want to measure the use of the materials and then what is the embodied carbon of that. So, but they want to make sure that all these material quantity, all these emission factors has been certified. It's actually correct. So I heard that even in EU, they also consider the product digital cert. Okay, so every data, every material actually have the cert and then trace the source, etc. So we try to consider this one and then use blockchain to ensure the certification. So that's why we developed this kind of the carbon auditing framework for the construction materials certification. And that many two parts. One part is we try to decentralize the data. So basically it's similar concept as I've mentioned earlier. Each one have their own, let's say the electricity bill, they have their own, maybe the procurement order, etc. All this document, but they actually have the hash code. And then this hash code will generate a chain and everyone share the same chain, something like that. Another thing is the privacy. So they will preserve the privacy and then for the data sharing. So for the first part, as I mentioned, then basically every people share the same chain, okay, of the hash code. of the certificate and the relevant document. And the second part for the privacy, the different 2 levels of the privacy. Basically, they try to use a key to encrypt the data before they upload. So basically this concept. So because the work is still undergoing, so I don't share too much details here, but later then probably when we really have the implementation, then I can share more. And then after all this, then in construction, we have another application, which is cost, okay? And then we found out that cost management is particularly, we try to blockchain some sensitive data, okay? But cost is very sensitive, and we don't want the cost information of one subcontractor to be shared by another subcontractor. So that's why we try to use the key to manage all this data. And then so we first of all have the data model of the cost and then put it in the smart contract and stuff like that. Then this one probably is straightforward. But what is more interesting is about the access control, maybe is actually easy. But what is actually more interesting is the re-encryption, okay? Because as I mentioned earlier, in a whole project, then sometimes what we encounter is at the very beginning, we may not know the whole team. At a later stage, we may have some subcontractor coming in or the material supplier coming in. And then let's say if I have a piece of the information, okay, or put it this way, you can imagine that for password, then maybe if I have a new people, I just share the password to the new people, it's easy. But let's say if I encrypt not using password, I encrypt using your key and my key, okay, or the key of 3 people. I have a new member joining, then I need to also add his key to the encryption. How can I add a key on encrypted data already? So one way is we need to decrypt the data and then re-encrypt using the 4 key instead of 3, something like that. But there's another technique is we may not need to decrypt. Okay, we can actually mathematically re-encrypt the data, okay, based on the already encrypted data. So this is actually something that we try to do because there's a risk if we decrypt the data and in the middle there's some intervention. So we try to see how we can re-encrypt the data using additional key. So this is actually the whole concept of that. So that's why you can see if I have a new member joining, then we re-encrypt the data. So this is something we were trying to do. And then we also apply this one for the interim payment record because in construction, we have one problem is that we may, the whole team may want to see who have paid to the main contractor. So sometimes what we have seen is the subcontractor have not get payment because they may not know the client have paid the main contractor. Okay, so they still wait and wait, etc. But in fact, maybe is it possible that we have a higher information transparency? Let's say if the client have paid the main contractor, then everyone will know. They will know the status that the main contractor has been paid, but the amount actually will be unknown. So can we make sure that this kind of the encryption or the security can have a partial encrypted, okay, or partial transparent? So this is actually a concept that we try to make it in the interim payment. So we try to concept this one, and then we have a partial transparent, partial non-transparent information, and then apply this one to the interim payment. So this is actually the main concept. And the last application we have done is the facility management. So facility management, what we encounter is we try to encrypt the occupancy information, particularly like the sensor information. So we may wonder how comes, because let's say, even sometimes I will share, the big box may not know, may not want other people to know whether they are in office or not. Okay, so for example, maybe they're on trip, etc. They actually want all this sensing data, occupancy data, the maybe the temperature data, etc. to be secure. Then is it possible that we can enhance the security of the all this FM? Another thing is, for example, if there's any repair, maintenance, can we also make it as a traceable record so that if whoever order or whoever have to repair, then we know who have changed and then we can trace back. So we apply this concept into this kind of the FM application, something like that. And then basically, again, we try to have the data model and then put it in Hyperledger Fabric and then just share the information and stuff like that. And then we apply this concept to one building. And particularly, this is a building of a bank, so Citibank, okay? So they have the office. They actually allow us to have the dual twin of that platform. And then we blockchain part of the energy data. Okay, and then with this one, then we use the B model of that and then connect with the backnet, something like that. So we develop this kind of platform. We have the corresponding floor, and then this one is based on IFC, it's web-based platform. And then we have the energy data, and then you can see that with the energy data, then we can real-time know what will be the operation information and the temperature, etc. So basically, it's a web-based dual twin platform. But what is at the back end is we have the blockchain of at the back end of all this data, particularly some sensing data. We have selected them, and then we have the data model, and then we put this in the record. So this, where's the blockchain part? So probably it will be at the later stage. Okay, so when someone try to log in, then can see that there will be the all this in the blockchain. So for example, all these have the corresponding blockchain platform, blockchain record, and then for example, who have changed the chiller, who have, for example, do some repair, etc. All these have the corresponding blockchain record in the Hyperledger Fabric. And for all these applications, then we have collaborated with different parties like contractors or facility owners, and also some platform vendors. We also get support of the government and CIC. So just a recap, over this time, then I have shared with you the blockchain application of different tasks or different stages throughout the whole life cycle in a distributed way and secure way. So this is actually something that I think will open up the opportunities, because we found that for different applications, the information that we want to blockchain or secure will be different. And also the problem about the data sharing, the mechanism, workflow actually may also be different. So that's why I think this will be interesting for us to study more. And then in particular, what we try to do is, just going back to the digitalization roadmap. If you look at this digitalization roadmap, then I would suggest you to take a look on this picture. Why we always say that digital transformation of our construction industry or sector is so difficult, because if you look at the task for the whole life cycle, actually we compare with manufacturing, but in our industry is involve a lot of tasks actually. What I share is only some of them. You can see that in the planning stage, we need to do many like the EIA, the drawing generation, many studies, and then the detailed design planning stage, fabrication, all the way to the operation. And then there's so many tasks. Is it possible that we, in the future, apply blockchain technology to some of them? And then, what I've demonstrated is only some major tasks, but you can see that there are many other parts of our sector that needs the security concern. So if we apply blockchain to enhance security, how? So this is something that I leave to the floor, and maybe in the future, we can open up some more research idea. So to wrap up, actually our group also not only work on blockchain, we have worked on the BEAM as the centerpiece of dual twin, and then link with other technologies. For example, AI computer vision on construction safety, simulations for structural design, IoT, GIS, etc. And then we actually consider the full life cycle. Before I finish, then I would like to do some kind of the advertisement. And actually, able to talk about the CBC, the consortium. Actually, every year the consortium have organized the Construction Blockchain Conference, and this year we are very fortunate and honored to organize the Construction Blockchain Conference in Hong Kong in a hybrid mode. And we have invited some of you to be the keynote as well, and then to come to Hong Kong. And the call for paper, actually the deadline is the August 31st. Okay, so this is the deadline. I hope all of you will try to, I don't know whether you have been to Hong Kong, but I think Hong Kong just opened the border early this year, and then there are many exciting things, and we may also go to the surrounding areas like Macau, etc., to see whether you're lucky, and then something like that. Okay, so I hope that you can support us, even though you cannot come physically, but you can still join us online. And in our promotion, our group will also organize another conference in 2025 January. Then we will also have one stream on blockchain. So in that one, then is about the computing for civil engineering in general. And I mentioned this one because the call for abstract will be June of next year. So for those of you who plan to submit papers, and then you can take this as a note, and then no matter it's about IoT or digital construction, then you're also welcome. So this is actually what I would like to share, and thank you very much. Yeah.